Hi, good afternoon. We will soon get started with the third lecture on kinematics, wherein we are working on the variable acceleration scenarios, wherein a particle moving along.
Sir, you're on mute.
Sorry about that, beta. Okay, so we're still waiting on Chavi. Okay. But for the folks on YouTube, for the students joining in on YouTube, we will soon be starting with the third uh, application or third type of application, or rather, I should say, we will be talking about number four today. Hi, good afternoon. Okay, beta, let's get started. Okay. So yesterday, beta, we finished number three. Any questions on the first three different applications of basic definitions of acceleration, velocity, displacement, position?
Sir, that pulley question that we had yesterday, I did not really get time to do it yesterday, so I'll do it today. And if I have questions, I can text you, right?
Yes, beta,
Or-
of course.
yeah. So everything else is clear.
Okay, good. Hi, Manan. Good afternoon, beta. Beta, you will be joining us on Wednesdays or you'll be joining us on Thursdays? Okay, Manan.
Sir, I am free on Mondays and Wednesdays.
Oh, you're free on Mondays and Wednesdays. Okay, ठीक है बेटा. So let's start with question type number 4. So as a quick recap, what are we doing? We are looking at the scenarios wherein a particle is moving in one direction, along one direction, but not with the constant acceleration, but with variable acceleration. And we have looked at three different ways. This our knowledge or understanding of the basic definitions can be applied, right? In physics, it's all about mastering the different applications of the concepts. Concepts तो चलो simple है, straightforward है, समझ में आ जाते हैं, but the true goal is to master the different applications. So starting with number 4 today. So while this is coming up, I have shared a list of 70 odd questions, which are good set of questions to practice from the JEE Advanced standpoint. Okay, and but you should attempt them only after you have done the JEE Mains, NT Abhyas, and the previous year JEE Advanced questions that are there in the site. Okay, so now in this one, so you might be given acceleration of a particle as a function of position. So yesterday, the last one that we looked at was where information was given as acceleration was given as a function of time, right? So there you were able to integrate that and get the expression for velocity as a function of time. And from once you have the expression for the velocity as a function of time, you were able to find the expression for position as a function of time. Yes, but now we have acceleration as a function of position x. So how do we deal with such scenarios? So if we are given acceleration of a particle as a function of x, then recall our definitions. Acceleration is defined as rate of change of velocity or dv by dt And how is the velocity defined? Velocity is defined as dx by dt. Now, here in this one, this is given as a function of x. Okay. Now, if you were to divide equation 1 with equation 2, what will you get? You will get a by v is equals to dv by dx, or a dx is equals to v dv. Now, if you integrate it from the initial, so whatever the values were at the initial position and the final position, right? So let's say you know the velocity at the initial position, let's call it u, final position v, and this one is, let's say initial position is xi, final position is xf, right? So if you are given the acceleration as a function of x, then the left hand side now is a full integral of x, so you can integrate that independently, and the right hand side is a full integral in the v, so you can integrate that and you will get v square by 2. So from here you will get the expression for velocity as a function of position. Now, if you are interested, or if the whoever is asking the question, whether the question is in JMain, JEE, or wherever, if the next step is asked, what is the next step? Talk about the position as a function of time. Then once you have v as a function of x, then use the definition of the velocity, which is dx by dt. Now if you take dt on the left hand side, you get dx. Now if you integrate, you will get the position x as a function of time t. Or not as a function of time t, but rather you will get the relation between the position and time t. Okay. So with that knowledge, let's go ahead and solve few questions. Let's start with this one. Hi Nikhil, good afternoon beta. So once again, for the students who are joining us on the YouTube, feel free to ask your questions as I kind of talk about the theory, or as we are discussing different questions. I'll try and address those questions to the best I can. I may not be able to respond right away, but I will pick them up as and when I get the opportunity. So please go ahead and attempt these questions on the screen. Any doubts, any questions?
Sir, 2 meter per second.
2 meters per second, okay?
Yes, sir, 2 hour.
2 hour, okay? So Chavi, while you are working the last few steps in your calculation, Manan, Ruchika, beta, let me ask you this question. This relation, integral a dx, from some initial position to some final position is equals to integral v dv. What does this remind you of? But what does this remind you of? Does it remind you of the work kinetic energy theorem? If I were to multiply
Yeah.
it by m on both sides,
Yes, sir.
so this will be f dx is equals to m vf square and by half m vf square minus vi square, which can be written as delta k, and this is defined as the work done by the force F. Correct, no? Okay. Okay, so the question on the YouTube is, sir, 46.4. Okay, I'm not able to fully read this one, but looks like the question is, can I crack the JEE advanced exam?
Sir, got it. It took me some time to understand what to do.
Okay, you got it? Okay, good, Beta, good. So let's move on to the next question. Let's quickly jump onto the NT Abhyas question. So we'll try and do 3 questions of each question type, and I'll count on you guys to do the rest. So let's go ahead and attempt this one. Okay, so let me pick up this question. So Ruslam, your question is, if you have a lower percentile for PWD, can I, okay, my guess is that your intent is you're trying to understand if you have a lower percentile, can you approach JEE advanced exam? Can you crack the JEE advanced exam? But in all reality, it's all about you can crack it if you are ready for it. If you have done enough practice, if your concepts are clear, then of course you can crack the exam.
So 20 meter per second.
Okay, 20 meter per second, got it. So beta, but the percentile that you are referring, so some of these exams, whether it's JEE Means or some other exams, they
Yes, it's a 20 meter per second.
okay, got it, beta, got it. So they are a reflection. So they're a reflection of your preparedness. Now you may have not done well in those exams for multiple number of reasons, right? But if you think your practice is good enough and you have your concepts pretty well nailed down, then yes, then sky is the limit, right? But going by whatever the percentile that you talked about,
So I'm not sure how to do this question.
Okay, beta, I'll come back to you in just a moment. Yes, beta Chavi, please बताएं.
So I'm not sure how to do this question.
Okay, so Ruchika, Manan, how did you guys approach it, beta?
Sir, पहले sir integral ADX के लिए sir area under the graph ले लिया sir.
Okay.
Sir उसको v square by 2 minus u square by 2 रख दिया था. सभी v integral v dv वही है.
Okay. So Chavi beta, if you recall, this ADX is equals to v dv. Now, what does this represent, beta? Beta, this represents the area under the A versus X curve, right? Area under the A versus X curve. Correct, no? Yes, beta? Chavi?
Yes, sir. Ha, sir. Yeah.
It was a small trick, no? It's kind of a cute trick, but simple enough. Yes?
Yes, sir.
Okay, good. I know the mind wanders off. You try and figure out what is the relation between A and X so that you can integrate it. Correct, no? So you must have thought, okay, let me figure out the equation from 0 to 15 seconds. Let me work out the equation between 15 to 30 seconds. And then I'll independently calculate the integral. Is that how you were approaching it, beta?
Yes, sir.
Yeah, so that must be time consuming, and you might be wondering, why am I taking more time? So there was a slight shortcut there, that's all. So this is the JEE Advanced question from 1998. Please go ahead and attempt this question. Okay, Ruslam, if you are still with us, I hope you you got my point. But if you have any further questions, I'll try and address them better. For those who are joining us on YouTube, we are looking at the one of the applications wherein you'll be given the acceleration as a function of position x, and you'll be asked to determine velocity or some other information about the motion of the particle. And as I mentioned, if you're given acceleration as a function of position, then you can take your A definitions. A is equals to dv by dt and v is equals to dx by dt. From there, divide the two and you'll get the expression A dx is equals to v dv, which, as you will learn later on, is no different from your work kinetic energy theorem. That's what the work kinetic energy theorem says. Anyway, we'll talk about that in 2 chapters from now, but at the moment we are trying to solve this question. So the class online and the students are trying to figure out the solution for this one. So you can also try and join in this exercise and do these questions during the class itself. It's very important to build the ability to solve questions.
सर वेलोसिटी आ गया लेकिन सर टाइम नहीं आ रहा.
Okay, so what is the expression for the velocity, beta? Manan, what is the expression for the velocity of the particle as a function of position x?
Sir, half minus 1 by 2x
1 by 2 x.
1 by 2x. Sir, x denominator.
Okay.
Sir, and sir, इसको 2 से मल्टीप्लाई करना है. सर फिर रूट ले लेना. So the 1 minus 1 by x का root.
1 minus?
So square root of 1 minus 1 by x.
Okay. So beta, how are you thinking about the option B? How are you approaching it? How are you thinking about it?
Sir, v equals to dx by dt.
Okay. इसको करेंगे तो फिर क्या आ रहा है बेटा रिजल्ट?
सर वो सॉल्व नहीं हो रहा.
रुचिका छवि आपका भी ये आ गया बेटा एक्सप्रेशन फॉर वेलोसिटी.
Yes, sir.
Yes, sir.
Is it the same expression as listed here? dx by x square integral will be minus इधर आ गया 1 by x will be 0.5 1 by 0.5 that is 2 minus 1. Is that right? But you are trying
Yes, sir.
the generic x from 1 meters to some x. So you got the expression 1 by x minus 1. Okay.
सर एक क्वेश्चन था,
Yes, बेटा.
इसमें आपने k by 2x स्क्वायर का इंटीग्रल क्यों लिया? वो तो फोर्स है ना?
Divided by mass. Mass is 1. कितना है? Mass.
सर वो k नहीं आएगा सर, वो 1 हो जाएगा।
अच्छा बेटा, वो डिवाइड होगा ना मैथ से, तो मैथ्स और दोनों सेम है तो वो कट रहे हैं.
हाँ सर, दैट्स व्हाट।
My wrong. So that's what you have. बेटा माइनस साइन का एक बार चेक करें. This is what I'm getting.
Yeah, so even I'm getting minus sign.
Okay. Manan?
यस सर।
तो आपका क्या आ रहा था? 1 माइनस 1 बाई एक्स आ रहा था या 1 बाई एक्स माइनस 1?
तो 1 by x माइनस
1 बाई एक्स माइनस। तो अपना ये v आ गया बेटा. नाउ इसको थोड़ा सा सिंप्लीफाई कर लेते हैं. द एक्सप्रेशन फॉर v इज स्क्वायर रूट ऑफ 1 माइनस एक्स बाई एक्स. इसको अगर अपन लिख लेते हैं dx बाई dt, तो दिस विल बिकम इंटीग्रल dt is equals to square root of x upon 1 minus x dx. Now x going from t equals to 0 to some time t, and your the x going from 1 meters to 0.2 meters. Okay, इसका इंटीग्रल we do, can we use some kind of substitution? Can we have x is equals to, let's say, what will you take? X is equals to sine square theta. Will that help if you were to try and do it? What else can we do here? Square root of x upon 1 minus x dx. Let's quickly do this one. So if I were to put in x is equals to sine square theta, what do we get? So we'll get dx will be what? Dx would be 2 sine theta cos theta d theta, and we will have sine square theta by cos square theta. The sine theta by cos theta comes out, right? So square root of x upon 1 minus x then will become sine theta by cos theta, and then you replace dx by this, so you will have cos will cancel out, you will get 2 sine square theta d theta. Okay, we should be able to solve that from there. और कोई और तरीका है तो बेटा वो भी सोचें. If there is any other way we can approach this integral.
सर आप एक बार वेलोसिटी वाला बता सकते हैं?
वेलोसिटी वाला एक्सप्रेशन बेटा इंटीग्रल.
हाँ सर, एक बार आप बता सकते हैं आपने क्या किया?
अच्छा बेटा, तो we had a dx, integral a dx is equals to integral v dv. So that was our starting point. Acceleration is force by mass. So force is minus k by 2x square divided by mass into dx. Starting from rest, no? Yes. And here x is 1 meters to some x. इसको इंटीग्रेट करेंगे बेटा, तो you will get माइनस ये k और m की वैल्यू दोनों 10⁻⁻2 है, a किलोग्राम है, and k is in again SI units 10⁻², 10⁻² will, so you will get minus 1/2. Now integral of 1 by x square, that will be minus of 1 by x. This minus minus will cancel, and the limits are from x is equals to 1 meters to x, equate that to v square by 2. That's what we did with. If you put in the limits, that's what you will get. Okay?
हाँ sir, so the first one where we have to find the velocity when it is reaching 0.5,
Right.
so we just take the value of x to be 0.5, right, at the as the upper limit.
That is correct. That is correct. तो जो ये x दिखा है ना, तो यहाँ पर आपका 0.5 हो जाएगा. You will get your velocity at that time. The second part says find the time at which it reaches x is equals to 0.25. Find the time it reaches x equals to 0.25. So we need to figure out the relation between the position and the time. Right? So for that we use v equals to dx by dt. And you guys can use the substitution, x is equals to sine square theta. यस बेटा, सॉल्व करके बताएं क्या आएगा आंसर. मनन सॉल्व हो रहा है. रुचिका,
Yes, sir.
are you guys able to progress or shall I do it?
Sir, हो रहा है.
Okay. थीटा कहाँ से कहाँ तक है? पाई बाय 2 to पाई बाय 6. और साइन स्क्वायर थीटा को कैसे करेंगे? साइन स्क्वायर थीटा को आप उस पर लिख लें एज
1 minus cos to theta by 2.
there we go, 1 minus cos to theta by 2. From there you should be able to solve.
Sir, आपको I did not understand how you got the trigonometric ratios over there.
So but the expression we have is this. So the expression is what was the, so v was square root of x upon 1 minus x dx is equals to dt. Is this part clear? How we wrote this?
हाँ sir.
Found the expression for v?
Yes sir, this much I got.
You got, okay. Now integrate this using the substitution, method of substitution. Substitution that we can use is, there are many ways you can do it, but let's use x is equals to sine square theta. Then what will be, this is change of variable we are using, so dx would be 2 sine theta cosine theta d theta. What will be the limits? If x is equals to 1, your theta will be pi by 2. If x is equals to 0.25, that is the upper limit. For that, sine square theta will be 1 by 4, sine theta will be 1 by 2. That means theta is 30 degrees. 30 degrees is pi by 6. So using the change of variables for x and then writing the expression for dx, our integral changes to integral limit will become pi by 2 to pi by 6. Square root of x upon 1 minus x will become sine theta by cosine theta, and dx is 2 times sine theta cosine theta d theta. You cancel out cosine theta, so you get 2 sine square theta. So 2 will come out. Sine square theta, I can write this as 1 minus cosine 2 theta by 2 d theta, pi by 2 to pi by 6. Let me move on to the left hand side. Let me write it here. So then what do we have? So we get the integral becomes pi by 2 to pi by 6, 1 minus cos 2 theta, right? So what is the integral of 1? That will be theta. So theta limits going from pi by 2 to pi by 6 minus cosine 2 theta. Cosine 2 theta integral will be what? Integral will be sine 2 theta divided by.
Yes, sir.
Then you put in your limits from pi by 2 to pi by 6. Make sure that we have not done any miss here in terms of the, okay, we have not. And this should be equals to the time. So what do we get here? So this becomes pi by 6 minus pi by 2 minus half sine 2 theta. What is sine 2 theta? Sine of pi by 3, that is sine 60, minus sine of pi.
So 0.
That will be 0. So this will be equals to time t. So what do we get from here, beta? So we get are we getting the negative value here for time? What's going on here? Okay, let's address the negative sign in just a bit. So what is the value here? So pi by 6 minus pi by 2. So what do we get? So that will be 2 pi by 6 or pi by 3. So minus pi by 3.
सर ये सब करके सर -1.48 आ
minus 1.48 सेकंड आ रहा है. ठीक है, अब माइनस साइन को एड्रेस कर लेते हैं बेटा. माइनस साइन, एनी guesses as to why we might be getting a minus sign? If you look at the v is equals to dx by dt, right? v is equals to dx by dt. हमारा जो v का expression आया है, that is square root of so the expression we got for v square, recall, is v square is x upon 1 minus x. That's what we had now, beta?
Yes, sir.
Okay. So now the if you see which way the particle is moving, so when we wrote the expression for v, we wrote it as square root of x upon 1 minus x, right? But the particle is actually moving towards minus x, right? And why do we say that the particle is moving between so it started at x and it's moving towards the smaller value of x, correct? No? So the velocity is actually negative, not positive. So when you write v, we should have used minus square root of x upon 1 minus x is equals to dx by dt. Then that expression would have been right. Then we would have gotten the answer plus 1.48. So now let's think through it. So why do I say that the velocity is negative here? How can I say that? So let's quickly see. So the particle starts from rest at time t equals to 0. Its velocity is 0, no? And it is at uh, x equals to 1. Look at the force. Force is minus k by 2x square. Minus k by 2x square. That means the force is in the negative x direction. Negative x direction of force है, that means the acceleration is in the negative x direction. If the acceleration in the negative direction, the velocity is going to be in the negative x direction. That much part is clear?
Yeah.
So we missed out on that part. So we only caught up to it when finally our answer came to be negative. So what does this tell us? Well, if you had gotten this in your exam, this is a older JEE when you were supposed to submit the, let's say 1998, when you were supposed to submit your answer sheets, right? Submit your solutions. If you would have missed it, you would have lost almost 70 to 80% of your marks, right? But in today's day and age, if you have gotten minus 1.48, then you would have quickly figured out it cannot be minus, it has to be positive. Then if you were in a rush, you could have still chosen the option kind of B here. Even though these options are made up by us, they were not the actual JEE advanced option. This was a subjective question, so there were no options there at that time. Okay. So the part is clear, Manan, Ruchika?
Yes, sir.
Whenever we are always, so that's maths or physics, even though such scenarios I've seen not that many, but whenever you're using something square is equals to some value and you're trying to say v is equals to, or whatever the variable is equals to square root of something positive, right? Then whether you take plus square root or minus square root, you have to be careful there. So in this scenario, after the fact, you could have figured it out कि actually में ये तो negative side में होना था. ठीक है ना? आगे चले? Okay. Clear ना बेटा?
Yes,
हाँ
sir.
sir.
Okay, good. Now let's look at this one. Up acceleration will be given as a function of velocity v, not as a function of time, not as a function of position x, but as a function of v. कैसे करेंगे? बड़ा ही simple है. A is equals to dv by dt. So A, acceleration A is equals to dv by dt. dt को लेफ्ट हैंड साइड में ले आए, a को नीचे ले आएंगे. Now the right hand side is a function of v only, so it's a full integral. So you can integrate that. You can integrate the left hand side. You will get, let's say 0 to time t, some initial velocity u, some velocity v, and you get t is equals to integral dv by function of v from some initial velocity to some final velocity. Clear है ना? Simple. सीधे एंटी अभ्यास के क्वेश्चन करेंगे. वैसे 2019 के क्वेश्चंस आर आल्सो रिस्पेक्टेबल. So let's take a look at the JEE Mains 2019 question as well. For those on YouTube, so we are looking at the scenario wherein the particle is moving in one dimension, moving along a straight line, and the acceleration is not constant but changing with time. So one of the applications is wherein the acceleration might be given as a function of velocity v, and then you'll be expected to find the expression for v, or the expression relating v and time t. From there, you can actually figure out the position as well as a function of time t, which may or may not get complicated in certain cases. Manan, so once you find the expression for v, you will have to go ahead and find the relation between your position and time t. और सॉरी, you don't have to worry about the position. ये तो आपको given है ना कि it reaches the zenith. Zenith means the highest point. तो वहाँ पर तो बेटा velocity zero रहेगी ना. So now you have the expression relating the velocity with time t. So you should be able to figure out the time taken to go from initial velocity v0 to final velocity of 0.
सर बी आ रहा है.
Okay. Okay, beta. The acceleration is f by m.
Yes.
The ball is thrown upwards. The ball is moving with certain velocity at given time t. What are the forces acting on it? Mg is acting downwards, and besides mg, there is another force which is proportional to its speed, m r or m gamma v square, m gamma v square. Both the forces are in the downward direction, so your acceleration is in the downward direction. So I'm going to use the minus sign here to reflect that part. So what do we get? So we get minus m g plus gamma v square pi n. Equating that to dv by dt. यहाँ तक पहुँच गए बेटा, छवि आप ही पहुँच गए. So both Manan, you are working on the integral here beta.
Yes, sir.
What substitution are you guys using? You can get a hint from the given options as well, but what if you were to try v is equals to 1 upon gamma, or you could have taken gamma out here. One and the same thing. So what if you were to take v is equals to 1 by gamma, or rather g by gamma,
So tan square theta.
square root of g by gamma, tan theta.
Sorry, a square plus x 1 upon a square plus x square के लिए यूज करते हैं.
Sorry, what is it beta?
सर ये सब्स्टिट्यूशन 1 upon a square plus x square के लिए होती है ना.
Correct.
ये tan theta.
Correct. So Ruchika, what is the derivative of tan theta beta with respect to theta? Manan, what is the derivative beta?
So sec square theta.
Sec square. So that means you get minus t is equals to, limits will go from v0, so at v0 theta would be tangent inverse v0 into gamma by g, and finally when v is equals to 0, then your theta would be 0 as well. Okay. So the integral will become integral from tan inverse gamma by g, upper limit is 0, so dv upon g plus gamma v square, so that will that'll become dv upon, or in fact let me write this down, so dv is square root of g by gamma secant square theta d theta, and in the denominator you get so you will get g will come out, you will get 1 plus tan square theta right beta, 1 plus tan square theta. And what is 1 plus tan square theta? Secant square theta? Yes? No? Shavi?
Yes, sir.
So you will get 1 upon square root of gamma g, theta integral will be theta, limits are from this sign already outside, from t, or let me just do this. So 0 minus tangent inverse 0 gamma by g. That means time t, let me write it here, would be 1 upon gamma g, tangent inverse square root of gamma by g. Correct now?
Yes, sir.
Okay. Looks like the option B, is it? एक एनडीएस अभ्यास का क्वेश्चन देख लेते हैं एंड देन विल मूव ऑन.
Sir, D आ रहा है.
डी आर है. ओके.
Yes, sir, DR.
Okay.
Yeah, sir.
Okay, good. We are above 6, so let me. So we're not going to have the class tomorrow. So is it we keep going for another 10-15 minutes?
Yes, sir.
Okay. You're okay, na beta?
हाँ sir.
Manan? Okay. Acha. Now we're going to get into some interesting applications with constant acceleration. ठीक है छवि? ये जो बेटा whatever we studied on the variable acceleration, was this covered in the classes that you had?
Yes, sir, but the thing is we haven't really done substitution properly yet. Like I've done it on my own, but not properly. So I'm not really comfortable with that. But बाकी किया हुआ है.
बाकी किया. Okay. Fair enough. ठीक है बेटा, substitution, in good thing is in physics, the substitution required, they are not that complicated, right? I know since you just getting started with integration, all of you guys are starting with integration, so it might feel a little bit odd, but keep doing it. It'll get simpler and simpler as you go. अच्छी बात. Now we're gonna look at scenarios with constant acceleration, and this is the simplest of applications that we're gonna study, where you're gonna use the two equations v is equals to u plus at and s is equals to ut plus half at square to determine the unknown. Once again, ध्यान क्या देना बेटा, ये अपने पास दो इंडिपेंडेंट इक्वेशंस हैं. कितने वेरिएबल्स हैं? 5 वेरिएबल्स हैं. So to be able to solve the given situation, you need to know 3 of these 5 unknowns or 5 variables. You should have only 2 unknowns. Out of the 5 variables, 3 should be known. You can address the other 2. Okay, you can find them using these 2 equations. Any other equation, v square is equals to u square plus 2as, or s is equals to vt minus half at square. All those are the equations you will get from these 2 equations, right? अब उनका क्यों करते हैं वो equations क्यों निकालते हैं? Because right now you are dealing with 5, right? But you can जैसे अब v is equals to u plus at है, इसमें कौन कौन से variable present है? 4 हैं. Final velocity, initial velocity, acceleration and time. इसमें आपका डिस्प्लेसमेंट नहीं है, डिस्प्लेसमेंट वाली में आपका फाइनल वेलोसिटी नहीं है। ऐसे ही यू कैन फाइंड एन इक्वेशन जिसमें टाइम t नहीं है, देन यू कैन फाइंड एन इक्वेशन जिसके अंदर आपका एक्सीलरेशन नहीं है, राइट, एंड यू कैन कीप गोइंग। So in total there are 5, but typically I say just use these 2, right? Doesn't really take much time to figure out how to use them. So you don't need to mug up any other equations. Let's focus on the application. Let's start with NTFS questions.
Sir, 4 milliseconds.
4 milliseconds. Okay.
इनसे 3.75 आ जाता है जिसको राउंड ऑफ करने पे 4 मिलीसेकंड आ जाता है.
Okay. So everybody got it?
Oh, yes, sir. Yeah.
Oh, okay. Manan?
Yes, sir.
Okay. ठीक है, these are simple questions. आप लोग कर लेना अपने लेवल पे, ठीक है बेटा?
Yes.
हाँ, JEE मेंस में somehow lately JEE मेंस में इस वाले में ठीक ठाक questions आ जाते हैं. Just go through them. Let's look at this one. 1D motion in the same direction, 2 or more sections with same A. क्या मतलब? पार्टिकल है, एक ही डायरेक्शन मूव कर रहा है. It's not changing direction during the journey of interest. और typically what would be the scenario जहाँ पर velocity और acceleration, initial velocity and acceleration same time में है, then of course the particle will not be changing the direction. Right? जैसे कि मान लिया आपने बॉल को ऊपर से ड्रॉप कर दिया किसी हाइट से. Now we know अगर आप ऊपर से ड्रॉप करेंगे तो initial velocity, or let's say you throw it, not just drop it, you throw it from the top of a building, then the initial velocity is in the downward direction, your acceleration is also in the downward direction, they are both in the same direction. Right? यहाँ पर साइन कन्वेंशन का बड़ा ध्यान रखना है. आगे वाले क्वेश्चन टाइप में आएगा, when they are not in the same direction, then you have to choose one direction as your positive. You can choose vertically upwards as your positive, or you can choose vertically downwards as your positive. That's your call. And if it is same thing is happening in the horizontal direction, constant acceleration, same logic will prevail there. Choose one direction as your positive and then stick with that sign convention, especially if the initial velocity and acceleration are not in the same direction. Anyway, so coming back to this one, अब क्या अब आपके लिए ना इतना simple नहीं रखेंगे, so we'll not keep it this simple for you. So what we'll do is, or what the examiners will do is, instead of giving you 3 out of 5 variables, right? 3 out of 5, V, U, A, T, and S. So instead of giving you 3 out of these 5 straight away, they will actually give the 3 variables in slightly tricky way. How? They might say the particle starts from rest. That means they have talked about the initial velocity. Initial velocity is 0. Then they'll say it travels the last 2 meters in 5 seconds. Last 2 meters in the 5 seconds, right? So interestingly, they have given you some information about the distance covered and the time it takes for the last part of the journey, and then you will have to figure out from what height it was dropped and what not, right? So there might be, just what do we have to do? Same equations will apply. V is equals to U plus AT, and S is equals to UT plus half AT square. But you have to patiently work through the given information. Remember, you have to, for a given journey, for once a particle is moving, it's moving along a certain direction with certain acceleration, then you need to know 3 variables. You must be given 3 variables for you to figure out the other 2, right? Let's jump into the question straight away. But am I clear in terms of what the question is going to be expecting here? So they will not tell you U equals to this, S acceleration is this, and some other information, the particle is, the final velocity is V or whatnot, right? So instead of giving you all that information, it will be given for different segments of the journey. Different segments of the journey. Let's solve one question. We'll do one J main, we'll do one NTA, we'll do one J advanced. Kare beta.
So 30 meters.
30 meters, okay.
Yes, it's a 30 meters.
Okay.
Yes, sir.
Why same thing? What all is given? They have given initial velocity is the distance covered is 10 meters and time is t seconds. Correct, Nobita? So they will always, you will always know three things. Let's look at the anti-abhyas question.
Sir, one issue please to solve.
Okay.
Sir, one is 3 to 5.
Okay.
Sir, I did not understand how to solve this.
Okay. Manan Bida, I'll come back to you and to share how you approached it quickly, right? What method you used. But anyway, let me first address it. So beta S is equals to ut plus half at squared. ये तीन अपने ड्यूरेशन से 10 seconds, 10 seconds, 10 seconds. Distance traveled is S1, S2, and S3. So for this one, if you assume the acceleration is A, then your S1 would be ut 0 plus half into 10 square, right? Whatever, let's say, let me write it 10 square. ठीक है बेटा? What is S2? In S1 plus S2 is easy to find. That is half. ठीक है बेटा?
Oh, sir, it's okay. I can get it now.
Manan beta, how did you approach it?
सर मुझे इसका रिजल्ट क्या था सर कि फर्स्ट 30 सेकंड नेक्स्ट 30 सेकंड और उसके नेक्स्ट में सर ऑड नंबर ही था सर लेकिन मैं भी इसी से करता
Okay, good. सभी बेटा चलें आगे.
Yes, sir.
The NT Abhyas questions are fairly good questions. So definitely give them a try and sharpen our skills.
So इसका तो ये आ जाएगा.
इसका भी ए आ जाएगा.
Yes sir.
चलो अच्छी बात है. अब इसको वैसे भी कर लो बेटा विदाउट मेमोरी ऑफ इट.
So मैंने इसे फॉर्मूला से याद है.
अच्छा.
सिर्फ सेम होना चाहिए.
Okay. So what are we gonna have? Your let me write it this way. Did I write it correctly? Half a.
Sir ये
यही है ना? N is equals to n starts from 0. So from t equals to n minus 1.
सर ये 10 सेकंड है.
What is it, beta?
सर ये क्या है?
Beta, this is distance traveled in nt seconds.
सर हमें तो सर n सेकंड निकालना है.
In n seconds. Distance traveled in n seconds, right? Half a.
Yes sir.
Right, distance traveled in n seconds. So what will be Sn? Sn is the distance traveled between t equals to n minus 1 and t equals to n. n minus 1 तक कितना distance traveled होगा? ये तो हो जाएगा आपका distance traveled in n seconds minus half a n minus 1 square. ठीक है बेटा? Yes? No? What is Sn plus 1? Half a n plus 1 square minus half a n plus 1 minus 1 square. Right? So n square. इनकी रेशियो निकालेंगे तो Sn अपॉन Sn प्लस 1 हाफ ए चला जाएगा तो यू विल हैव n स्क्वायर माइनस n माइनस 1 स्क्वायर डिवाइडेड बाय n प्लस 1 स्क्वायर माइनस n स्क्वायर. So what do you get? So in the numerator you will get n squared, so you'll get 2n minus 1 In the denominator, you will get n square will cancel out, so you'll get 2n plus 1. Clear?
Yes.
Chavi beta?
हाँ sir.
Ah,
Yeah, so initially I was getting B, but then I realized I flipped it by mistake. But yeah, it's fine.
okay. ठीक है. Good. So we'll take a break now. So let me just quickly show you guys where we at. बाकी इसके क्वेश्चन टाइप्स आप अपने लेवल पे कर लेना बेटा, छोड़ना नहीं है. जिसको भी जितना भी टाइम मिल रहा है कर लें, जितना करते जाएंगे बढ़िया है. तो अपने नंबर 7 तक कर लिया है, तो विल स्टार्ट विद नंबर 8 टुमारो. नाउ वी कैन गेट इनटू सम इंटरेस्टिंग फेस. ठीक है, तो अगले 4-5 जो रहेंगे इंटरेस्टिंग क्वेश्चन टाइप्स रहेंगे. रिलेटिव मोशन के बारे में भी सीखेंगे और कुछ चीज़ें सीखेंगे. विल बी फन. ठीक है बेटा, आई विल सी यू गाइस ऑन so we're not gonna try and have a makeup class on Friday, but rather I'll see you guys on Monday. ठीक है बेटा, I'll see you guys on Monday.
So Saturday, Sunday को class है ना?
Of course.
Yes.
तो सेम टाइम पे.
Sorry बेटा.
तो सेम टाइम पे.
मनन, sorry अपना फिजिक्स की क्लास ना?
यस. तो सैटरडे संडे.
ओ नहीं नहीं सैटरडे नहीं, केमिस्ट्री बेटा.
सो यस. सर और कल क्लास होगी सर रात को.
नहीं बेटा, कल just to so कल there is something important I need to take care of, so I will not be taking any classes tomorrow.
Okay.
Alrighty beta, take care. I'll see you in the evening. Bye.
Thank you, sir.
Thank you, sir.